are building this project on the mobile modular of UDK, which is multiplayer online battle arena. From this is the map of the arena. Each player spawns from one side of the map, left or right, and they try to push their army towards the opponent's base. There are 4 towers around the pillar at each side, which will defend themselves, and each side will also spawn units that help their player to push the force. So what we did, we first worked on the modular and make it with full gameplay and network. Then we add AI behaviors, mainly steering behavior, state machine, AI behavior, and neural network. Let's first play the demo. In the demo, the left side is using neural network, and the right side is using state machine. These are the neural network weight file. We need to put that into the UDK. So this is our player. We will set it aside and add 2 AI on each map, on each side to see their behavior. These 2 guys are using neural network, and these 2 guys are using state machine. So all 4 of them run to the middle center of map and start fighting. And when the units are died, they will go back and follow the next unit.
Just head on.
And when they're low health, they will go back to their base. So when they go back to their base, they will refill their health. And go up to fight again. Because they just killed the enemy. Okay. Yeah. That is the demo. For the state machine, we are using several states for its behavior. When they start, they follow the units and go to the front line. And when they are when there's enemy in their attack list, they will attack the current enemy. We're using a collision body around them as their site to add and remove enemy to their list. And when they feel they're dangerous, like there are too many enemy around them and too few allies around them, they will go back to the tower to follow the next wave of units. And when they are low health and anytime, they will go back to home. For the neural network, this is how we implemented it. First, we need to generate the training data. We have two ways to generate them. One is using an offline data generator program, which is generating fake data. That is at the beginning how we use it to test our program. Then we switch to in-game recorder that records player behavior. And the demo you just saw was using that set of training data. And for the real neural network program is an offline program outside UDK. It analyzes the training data and let it go through the black box of neural network and output the weight that is suitable for those data. Then in the UDK, we're reading the data again using a separate DLL file, and the input data will be used to make decisions, and the output of the neural network will still be states. So it's still using the same set of states as the state machine, but the decision making process is changed to neural network. And this is the black box we used for our neural network program. We have only one hidden layer, and the input are health and number of enemies nearby and number of allies nearby. And we add another parameter, is there an enemy around, which is 0 or 1, to give significance to that factor. And the output would be a number from 0 to 1, which indicates the state it should go to. And some problems we find during implementing it is one, some parameters may need to have more weight than the other, but it's hard to do that through training data. So we just hard code, like we pre-process the data. Like for example, the player's health, like it's not much difference from 500 and 600, but it's a huge difference from 0 to 100. So we changed a little bit, and the number of enemy around, we even add a new parameter for that. And also the sample constitution, when we test it, there are some behaviors we do a lot of times. For example, we repeatedly click an unit that will record it multiple times, and it affects the ratio. So that will be solved by playing it a lot of times and increase the sample body. And another problem is the location input and output. Right now we haven't deal with that because it generates a lot of problems, like from players click an arbitrary location, the XY axis has no much meaning to the program, and we force our player tester to click the units to make movement and attack. Yeah, that's it.
Wow. You're all yes.
Can I ask a question? So for your neural nets, how often would you update them, and then did you do this like per frame, or is that over a certain amount of time that you would choose to update, or at what point would you like make it update its decision?
Just like each frame.
So it's each frame.
Yeah, just like normal state machine.
And did you update all the weights each frame also?
Yeah.
The weight is
That's pretty impressive.
The
weight
is
is fixed.
So it's a separate process.
Yeah, because to generate the weight, it takes a long time. So we use a separate application to generate the weight.
Okay, cool.
We cannot do that in games.
That makes sense.
Yeah, so they're just, you have a fixed neural net once you're in game.
Yes.
Yes. So there is a problem when the players get level up, his health and his attack is increased. We cannot change the weight for the neural network, so it will cause some problems with for his behavior.
And then the last thing is like, how did you choose? Like, how did you, I mean, decide whether it made a good decision or not? Like, did you? So for it has a different state. Was it like, okay, you made the wrong? Like, what was the deciding factor? What did it
Like during the playtest to make sure we always make the decision. Yeah. And for the bad decisions, because its ratio is very low in the whole sample. The whole sample.
Okay.
Yeah.
We are basically simulating the state machine decisions using our brain. And
So
train
you're
neural network.
you're actively manually saying like, okay, you did a good thing.
Yes.
bad.
Yes.
Yeah.
Wow.
But because now the input for the neural network is small, so we cannot make complicated inputs for the neural network.
Sure. And one last question, like, how much training did you require before it actually started having good results?
About 2,000.
2000.
So when we get the data by ourselves, it's about 1,000 input data. But if we use the pseudo data generator, we can generate every number of the inputs.
Okay, cool.
That's very cool, thank you, excellent, wow. I think that's the first time in this class